Hello and welcome to SudoKanard. We're here to solve this shape Sudoku, which was created by Thomas Snyder for the WPF Sudoku Grand Prix 2022, sorry about that. This was worth 68 points, which was one of the higher pointers, but not the highest pointer. And it was definitely not the most difficult puzzle in the set, I think. I started my solving with this one, and I hope I'll be able to pull it off nicely during this video. So the special rule is that all of those pieces, all those shapes, must be entered into the grid, which means that this linear triomino must be one of those three. And it can be rotated, so if this is 8, 3, 6, then 3 is in the middle, but 8 and 6 form a pair on either possible positions around it. And those bent triominoes can be rotated but not mirrored, which means that if this is the 4 to 3, or if this is the 4 to 3, then the 2 must be here with the 4 and the 3. But I couldn't switch the 3 and the 4. Actually, that's the only constraint, seeing as the rest of those, well, if you apply a rotation, then you also apply a symmetry in some sort. Well, so what do we note? This is this uses a visual theme of digit 8. We can see an 8 here. And we can see that 8 appears in all of those dominoes. And there are lots of dominoes to place in the grid, which is the difficult part of it. We can note that 9 is on none of those shapes, so that's on this column and this row we can place a 9 right from the beginning. And we can see that one of those two has to be a 9, one of those two. You can see that one of those three must be a 9. So we know there's a 9 here or here, 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 here. I'm not sure it's worth pencil marking them actually. It doesn't seem to be so useful. There's a 9 somewhere in here as well, but actually we'll see more about that. So that pencil marking is really not useful. So where do we look? If you look at those bent triples, you see that 2 of them has to be here. So those 2 must have no digit in common, but this has 2 digits in common with this. This has 1 digit in common with this. So this does not appear in here, it must appear there. So that's the 2, that's the 3, that's the 1. And I will use some coloring to just say we don't need this anymore. So the remaining 2 here must be placed in this. So one option is to have 4, 3, 2 in this position and 1, 5, 6 in here. Or it could be the other way around. So 6, 5 and 1 here, and 2, 3, 4 this way. No, 2 should be at the knee, should be at the bend. That's it. So now we get a 7, 8, 9 triple in here. Let's move on to the triominoes, the linear triominoes. So you see that this does not include a 3, so it can only be this one, 7, 2 and 5, so 2 in the middle, 5, 7 on the outskirts. And this does not include a 1, so it's the one with 3 and 8 and 6, and the remaining 1, 3, 4, 1, can only be put this way. So there, all of this is basically used. And we are left with all the dominoes which need to be placed all around the grid. So how are we doing this? Well, the first row looks to be promising, because here the digits must be from 4, 5, and 7. And you can see that the only option is 4, 5. So we get a 4, 5 pair here. And this we get a 7, 9 pair on the row. Nice. Now 4 must be in one of two places, and in this. And oh, and here I didn't mention that we get a 1, 4, 9 triple. So knowing that 4 is here, the two digits here must be from 1, 6, and 8. And we know that 8 must be in one of them, together with 1 or 6. So this is either 8, 1 or 8, 6. I just type the candidates in. Then let's have a look at this row. Or is it the right place to look? I wonder, what did I do? That's correct now. So this column. In this column, we still need to place a 1, and we know that 1 in a domino here can only be with a 8. So there's the domino 8, 1 in this column, so this is not 8, 1, it's 8, 6. And 1 on this row can only be here, which places the 9 here and the 7 there. And that's a 4, 9 there. Here this is 5, 6, and 8, and here this is 2, 3, and 7. So we know now that 8, 6 has been used. And let's get back to this column. So we know that somewhere here we must have the domino 8 and 1. And once 8 and 1 is placed, we are left with digits 4, 5, 6, and 7. So we must place dominoes 4, 5, and 7, 6. So I just pencil mark this. So in this column, perhaps I should add another row here. It was easier to pencil mark on paper. On this paper solving, down there I put 7, 6, 4, 5, and 9, 1, 8, 1. So it was easier to note on paper. So we know that, what was I saying? 7, 6, and 4, 5, and 1, 8, I pencil mark them this way, are in this column. So we know that this, and I use some other coloring. I use yellow to note that I haven't placed those, but I have located those. In yellow, they are in this column. I notated it differently during the solve on paper. Now let's look perhaps at this row. So we don't use, we must use a tile, a domino that does not contain an 8. We must use at least one. And we see that only 7, 3, and 6, 5 are left, but 7, 3 can't be used because we already have a 3 on this row. So we will need to place 6, 5 somewhere here or there. So 6, 5, will it be here, will it be there? I don't know about that. But once we've located that 6, 5 is in there, the remaining values are 2, 8, and 7. So this is 2, 8, or 7, except that this won't be 8 because I know that there will be a 2-8 or a 7-8 domino in here. But most importantly, we will have a 5-6 somewhere. So now, in this column, I also need a domino that's not with an 8, and it will have to be 7-3. So we will have 7-3 somewhere in here, and the other one will use an 8. So it disambiguates all of that. So we will have 7-3 somewhere in here, and something with an 8. And something with 8 won't be 8-3 or 8-7. It won't be 8-5, so it will be 8-4 or 8-2. That's not so useful. But what is useful is that those two dominoes now must have an 8. So there must be an 8 here, and there must be an 8 somewhere in here. And this 8 is not with 1, 2, or 3. It's not with 6. So it's with 4, 5, or 7. So it's 8-4, 8-5, or 8-7. And what's more, 8 is not in here, so 8 has to be either in here or in there. So 8 and 1 won't be in here. So we know that 1 on the column will be in one of two places. There's a 1 in here. So this is from 4, 5, 6, 7. Note that this is neither of those. Oh, 1 here would need an 8 there. That doesn't work. So 1 is here, 8 is there. So 8 and 1 is really placed there. And those are from 4, 5, 6, 7. That's not 7, so that's not 6. And we don't quite know about those. All right. So what about this? This is not 4 or 7. I don't remember all that I've been saying. Oh, that's not 8, that is 8. And we need an 8 somewhere in here. We also need an 8 somewhere in here. So this was 8-2 or 8-7 and 6-5 at some point. It was really easier on paper, I tell you. 1 on this column can only be here. What about this? This must contain an 8. This is not part of the dominoes that we had located that did not contain an 8. So this is with 8. So that's 6, that's 8. And it disambiguates that. That's 4, 2, 3. That's 1, 5, 6. Up there we get the 4 and the 5. That's not a 2, that's not a 3. That's 7. So that's the 3. That's important. And here that's a 5. And on this row, 5 had to go with the 6. So this is the 8 must go here with 2 or 7. And 8 is not here, so 8 is here. And we have both dominoes, 8-2 and 8-7. So I'll use some coloring for that. Let's say red, 8-7 and 8-2 have been placed. I can even use green. And actually, the yellow one have been placed as well. So this, I still don't know about this. Oh yes, I know about this because in this column, the non-8 domino had to be 7-3. So 7-3 is the one that goes here. So that's 3 and 7, and it disambiguates the 2 and the 7. Oh, by the way, that's a 9, that's an 8. That's a 2, that's a 7. That's correct. Here I need 9 and 3. Here I need 2 and 4. Alright, this is now only a 6, accompanied with 7 on the domino, and that's a 4-5 pair. That's the 4-5 domino. Alright, so what dominoes are we left with? Well, 8-3 has been placed, so those are 5 and 4. So they are placed this way. And I'll use some more coloring. So now all dominoes have been placed, all shapes have been placed, and the rest should be standard Sudoku. So let's solve the remaining Sudoku. Here I need a 1 and a 9. So that's 1 here. Sorry, 9 there. Here I need a 9 somewhere, it's here. And this is actually resolved. That can only be a 9. It resolves the 3 9 buried here. Here I need not a 1, that's the 1, 2 and 3. So that's 2 and 3. This 9 places 4 and 9 over there. That's a 4-5 pair, so that's 5, 4, 5, 6 and 5. Here I need 4 and 6. Don't have them yet. That needs a 2 and a 6. Here, that's 5 and 7. 7 goes there. That's a 2, 4, 2, 4, 6, and 6 and 3. Oh, and that should be it, except that I must delete that. Yes. And that completes this puzzle, Shape Sudoku by Thomas Snyder, which was a spectacular side of things. But really, it was very well put together. It was perhaps my favorite puzzle on the set. And I'm happy I started with it during the contest. Thanks for watching this video. See you soon. SudoKanard.